so the talk in the end may not actually say that much about the origin of life, but I think that's okay because you've got 2 lectures on that tomorrow from it. But I will say what I mean by enactive. So the enactivism is a sort of, I guess, I could say it's a sort of revolution that's moving from science, or about it. But it's a collection of ideas, and one of those ideas is that life and mind are closely related. So you can cash that out in a number of different ways. You can say that life and mind are somehow very similar, and I hope it will become clear as I talk why you would think that. Or you could even go all the way and say that life and mind are actually the same. Some people, in fact, do say that. But the point is that if we take that insight seriously, then we need to have an embodied, embedded, inactive, and extended approach, not just to mind, but also to life. And that means that if we're thinking about the origin of life, then we're also thinking about the origin of all of these things. So that's the kind of point that I want to make towards the origin of life. And I believe that that's possible. I think well, it's something that some people are working on, and I'm going to show kind of my approach to this that I think is really quite good after. This is just an overview of the talk. So I'm going to give some background on autopoiesis. I'm going to talk about how autopoiesis can be itself be seen as extended, not just extended mind, but extended life. Then, do I keep talking more?
Let's see if it can be changed very quickly.
Okay, so well then this is only the overview anyway. So I'll kind of switch tack and talk about it from the kind of physics point of view. I'll talk about the importance of death and how death, the analog of death, can emerge in different systems. Then I'll talk about the kind of origin. Okay. So a kind of key term in the inactive perspective is autopoiesis, and for hard scientists, it's anyway. Sorry, this yellow sign is going to come up wherever there are words, or I hope wherever. I probably missed a whole load of them, but it's going to come up very often through the talk when there are words that mean different things to different people. So I'm going to talk about what I mean by autopoiesis, but particularly within the origin of life literature, it's come to have a meaning that's very different from what I view as being the original meaning. So this is just to be clear, I'm only talking about what I mean. So it was first proposed in 1972 as a tentative definition of life. And it tends to be written in this kind of very wordy form, which I'm not going to read out, it can be slightly frustrating because it sounds like a very precise technical term, but a lot of these terms aren't really cashed out, and they don't give examples of what they mean. But the basic idea is that something is autopoietic if it is a network of processes that whose net result is to reproduce that same network of processes, and at the same time to form a spatially localized individual. So that's roughly what this says. And this they put forward as a tentative definition of life. There's no reference to evolution here because they want to get at, so I got here through a process of evolution, but right now I'm alive, and that it seems weird to think that the fact that I'm alive right now is something to do with my evolutionary history or my possibility of having an evolutionary history in front of me. So they're kind of reacting against an evolutionary view of life. So, well, they don't give examples. So what a process is a key term here, right? A living thing, for Lecture1 and Varela, is a network of processes. So for me, examples of processes might be chemical reactions like a step in the Krebs cycle, very basic small molecule reactions. Another process might be the duplication of RNA or the transcription of RNA into a protein.
Another one might be transport across a membrane, so it's not just chemical reactions. But also, for me, things like learning and the development of a multicellular organism, those are also processes. So, and it's going to kind of become, I hope, a little bit clearer why I would choose to think of it that way. So the point here is that all of these processes are happening inside a cell or some other organism, and so you can look at it as a spatially localized individual, but you can also look at it in this much more abstract space as being the network of processes. What does it mean for them to form a network? Well, roughly speaking, we tend to think of these arrows as being, so a process like a chemical reaction produces products, and then another chemical reaction can consume those products. And so that second one is enabled by the first one. So a process can change the conditions that are required for another process. And if that's the case, we draw an arrow. And then the idea is that all the processes that take place within an organism all point to each other. There's a kind of, every process causes something within the organism, but it's also caused by something else within the organism. It's a fairly basic, fairly trivial concept, but it's kind of spawned this whole field of research. So the point here is that the organism is the network. The organism isn't this spatial object, because all of the atoms in this spatial object change every now and then. The actual object isn't the thing that stays invariant over time. It's the processes. And then the point that I think Maturana and Varela want to make is that all of these processes, the molecular ones and the behavior level ones, all form one network. It's not something that you can separate into a chemical level and then a behavior level that's on top of that. It's one thing. So that's why for them life and cognition are deeply related. So this sign is because within the enactive tradition, the term metabolism sometimes seems to refer to the entire network, including the higher level processes as well as the lower level ones. Whereas for biochemists, it really only means a subset. Obviously, this has to be here as well. So that was kind of whirlwind tour that I kind of felt was necessary to give you like this very, very brief introduction to autopoiesis. I'm just going to quickly whiz through a few examples of people who are working on specific modeling approaches that relate both to that autopoiesis idea and to the origins of life. So one example is Erin Agman, who's here in the room. What they have done is to create a model of a kind of basic cell-like thing, which has this roughly autopoietic structure. And the nice thing about it is that it has only a discrete number of possible states, and so they can map every possible perturbation that you can make to this thing and see how it changes. Erin has his computer with him, and he's happy to give demos in one of the breaks. So another example that seems to me kind of related somehow is some experimental work that's being done with oil droplets. These are actually not self-constructing. The oil doesn't make more oil, but the thing that moves within it, it's driven by chemical reactions, and you can see you get some kind of spatial structure formation. And the reason I mention that is that you can also do this kind of similar thing where you map out how it responds to different perturbations and how its behavior changes. And then one more example is some modeling work by Matthew Egbert, where he's kind of saying, so this is a model of a protocell, so it's like a simplified model of an organism, but it doesn't have sensors, but it's still able to move to where the food is that it needs, because it's able to respond to its own internal network and how well that's doing. And there are some other examples within Origin of Life as well. I just wanted to pick those more or less at random. So the first kind of more original point that I want to make is about whether you can see autopoiesis as extended. So yesterday at the end of Giovanna's talk, she talked about the extended mind and the example that Clark and Chalmers give of a boy called Otto a man called Otto who has Alzheimer's and can't remember things, so he has to write them down in a notebook, and the argument that that actually forms part of his mind. Now, I want to make the argument that things can happen outside of the body which still form part of life. So one example, there was a debate, or there is a debate within Enactivism about whether autopoiesis is compatible with the extended mind hypothesis at all. And so the reason for saying this is that I want to say that that autopoiesis itself is extended already before you even start to think about mind. So in this example, a spider wants to eat a fly, and to do that, it wraps the fly up in silk, and then it injects its digestive enzymes. Then it waits until those enzymes have done their job, and comes back and sucks up the sugar. And the point is that that's something that is part of this network. It was caused by the spider, and it causes things within the spider. And so it's kind of arbitrary to say that that should be counted as separate. So the point that we made here was that that you shouldn't confuse this physical boundary with this kind of more logical boundary. The existence of an individual is important, and we're not kind of trying to say that the distinct individuals don't exist or don't matter, but we do want to say that it's just wrong to think of life as only being what happens inside a single organism. In fact, this outer membrane is more like a node in this graph. It's one process, or it's the outcome of a process or a set of processes. So here's another really cool example of how life can be extended. If you disagree with everything that I say, at least you learn something awesome about narwhals. So this comes from a book from 1917 by Darcy Thompson. So the narwhal is a whale, and it has this long straight tusk, which is actually a tooth. And the weird thing about this tusk is that it's straight. That's very, very unusual in the animal kingdom. Usually what happens is that one side will naturally grow slightly more than the other, and it will become curved. The other weird thing about it is that occasionally a female, so usually only male narwhals have horns, occasionally a female narwhal will have two horns. And then when that happens, both of them spiral in the same direction and not in opposite directions, which is also really weird. Now, Darcy Thompson's conclusion about why this happens is that, well, he observes that the head is slightly asymmetrical. And that's because when whales and dolphins swim, they don't go just up and down like that. They actually corkscrew their way through the water slightly, and that's more efficient for them to swim that way. So then what he says is, well, if you've got a long tooth growing out of your upper jaw, and you're kind of doing this through the water all the time, then that's going to twist the tooth around. So the root of your tooth is actually going to rotate in your jaw as you grow. Goes around 6 or 7 times throughout the lifetime. And so because of that rotation, that's what keeps this straight and stops it from curving round. So so that's just a very nice example of how things kind of in the physical world. Yes, Eric?
Is it okay to ask questions in the lecture?
Yes, it is.
Okay. So that's an argument not only about correlation, but about causation.
Yes.
And we know how biologists love to hate such arguments if they can find a gene circuit that they can use to claim it's false. What is the status of that argument about causation? Do people believe that really is why it grows, or do they think that that's been encrusted with a developmental regulatory network that would do that anyway?
I had a look yesterday to see if I could find anything about that, and I couldn't. I mean, I could find only people, only actually a very small number of papers that cite this and say, look at this wonderful argument by Darcy Thompson, but I didn't find anything on any current debate about this, unfortunately, because it would have been nice. So yeah, and then the final example is your stomach biota. You'll die without those, and they'll die without you. So does it really make sense to say that you're completely separate? I mean, you can say that you're separate organisms. You're genetically completely different, but are you, as a kind of living agent, are you really two completely separate things, or are you in some way part of the same thing? And there's a lovely quote from Maturana and Varela that for me is kind of where I got this idea from, I guess. So they claim that this network of processes is equivalent somehow to homeostasis, a special form. So homeostasis means keeping something constant. And they say that this is a special form of homeostasis that doesn't just keep a variable constant. The thing it keeps constant is the organization itself. The fact that it's alive is the thing that's being kept constant. And anything that kind of tries to perturb it away from that will naturally tend to be resisted.
Can I ask a question?
Yes, of course.
So, in that phrase, it says relation static, right?
Yeah. That is one of the many words that's just used and never defined. But I think what they mean is they mean to say that the thing that it keeps constant is the relationships between the processes.
Right. But what I want to ask is, by that, it probably doesn't mean that the strength or the existence of the relationship is always constant within the given organism, right? It can change in some way, but in some way it is static. Is it correct?
I think it has to mean that, because obviously these things do change over development.
So in that sense, when something changes, like when you're not eating things, then there exists no relationship in some pathway of the digestion or something, right? But still, you consider this is a sort of constant thing.
Well, I mean, it may be that we have to save this for the discussion, but I think the idea of a process is something that happens over time. So, me sometimes eating and sometimes not eating that's still a process. But yeah, I don't know. I mean, I'm not their biggest fan or anything. I'm later in the talk I'll present my own perspective, which is a bit different. But we can discuss that. So anyway, what they then say after saying that it's about homeostasis is they have this nice quote: if one says that there is a homeostatic machine in which there is a feedback loop through the environment, so that the effects of its output affect its input, one is in fact talking about a larger machine which includes the environment and the feedback loop. So they're already saying in 1980 that for them, mind is very explicitly something that includes feedback loops through the environment. And note that it's not just the things that you affect that are part of your mind, or things that affect you that are part of your mind, but it has to be both, and it has to contribute to keeping you alive for them. Yeah.
That statement was about life, right?
Yes.
Isn't I feel like this describes life a lot better than mine.
Maybe so. Maybe so.
The whole point of mind is learning.
Well, I mean, you change some things, as you said, some things change and others stay the same, right? You change in order to stay the same, in order to not die. But I think...
What that part is the part of life, not die. If you distinguish life and mind, then anything that that statement described would be the life part.
Well, I think let's discuss later on whether one can distinguish life and mind, right? Because that's what they say you can't, and so. But yeah, no, it's great. It's a great comment. Yeah. Well, all right. So. This was kind of built on and developed by a number of people, because particularly when it comes to mind, there are things that contribute in some way to keeping you alive, but they're not necessarily necessary, right? Me having a nice job is great, but I would survive if I had a much worse one. So, and others are just detrimental. When I used to smoke, that was bad for my autopoiesis. It caused me to, well, it didn't cause me to die, I hope, but it could have done. So, Javier Berangiran has written about habits as being kind of autonomous agents in their own right, as almost being the basis, that being the basis of mind, that everything you do is something that benefits itself rather than necessarily benefiting you. In biology, you can also think about things like viruses. They're not autopoietic in Maturana or Varela's sense, but they're certainly part of the tapestry of life, a key part of it. So, you know, this is a kind of general point that I want to make as well, is that maybe this way of thinking about life as a collection of individuals isn't quite right. We should be thinking about it as a more broadly linked, richer tapestry in which there are sometimes individuals at various different levels.